Here's example 2. We're finding the zeros of a polynomial function. And so we're going to solve this like we did in 4.5 day 2. And there are no hints here. So let's try this. List all the possible solutions using the rational root theorem. And so remember that's P over Q, or how I mentioned it is B over F, the back over the front. Back is the constant, and so that is 8. So we don't have to worry about the sign because remember we listed as positive and negative. And then over 1. So we list all the possible factors of 8, and that's plus or minus 1, and then plus or minus 8, plus or minus 2, and plus or minus 4. And then there's no more other than that. So just 4, or really 8 that we could try. So we're going to use synthetic division to find the zeros. So there really isn't any magic to this. There's no secrets that I could give you. You just have to try them out, and then it's just a guess and check. So we're going to use synthetic division to see what works. So let's see if anything's missing. Oh, we're missing an x to the 4. So 5, 4, 3, 2, 1, 0. So I would try, though, start with 1 and negative 1 just to see if those work. So that's the first thing that I would try. Let's try 1. So 1, 0, 1, negative 2, negative 12, and negative 8. So this is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. And this is 0, negative 12. And we see that this doesn't work. We get negative 20. So this doesn't work. That's our x minus 1. So we can't use that one. Let's try negative 1. So 1, 0, 1, negative 2, negative 12, and negative 8. So drop down the 1, negative 1, negative 1, 1, 2, negative 2, negative 4, positive 4, negative 8, positive 8, and 0. And it works. So I know that x plus 1 is one of my factors. Now I want to go on because I can't factor this as it is. So this is a higher degree polynomial. So we need to do the synthetic division again. Now you don't have to start at the beginning here. We can start with where we are right here. Now because this is an 8, it's the same. We can use these same exact roots to see if the same roots will work, the same possible solutions work here. So what I'm going to do is, I think it's close. I think I can use negative 1. So let's try negative 1. It's just trying it. See if it works. So drop down the 1. 1 times negative 1 is negative 1, negative 2, positive 2, 4, negative 4, negative 8, negative 1 times negative 8 is a positive 8. Hey, it works. So therefore, we also know that x plus 1 works again. So it's a repeated root, right? So I know that I can write that as x plus 1 to the square. Now, looking at what I have here, our depressed polynomial, I notice that, I could probably factor this by grouping. So I can stop at this point. I don't have to keep on going. I can just factor with a known method. So just like we did before, we only had to do one synthetic division, and then we could factor. And so here, this becomes x cubed minus 2x squared plus 4x minus 8, and this equals 0. So factoring by grouping, this front half I can divide out an x squared, and on the back half I can divide out a 4. So I'm going to rewrite my x plus 1 to the square. Then this becomes x squared times x minus 2 for the front. Then here, this is a positive 4 times x minus 2. So that works out really wonderfully. So remember, we're factoring by grouping. Let's finish this out. X plus 1 squared. Then we can group these x squared and 4 together. So that's x squared plus 4. And then the x minus 2 and x minus 2 can be grouped together. So that's just x minus 2 equals 0. So then, and we find that this is, we can solve for that using the zero product property. So x equals negative 1 for that one. And this one is x equals 2. So on this middle one, I do have to solve for that. So that's x squared plus 4 equals 0. Set it equal to 0, and we solve. We will get an imaginary number, but it is asking for all possible solutions. So we square roots. That's good review in this. So when we square root, we get x equals, what is the square root of negative 4? So remember that negative becomes an I, and square root of 4 is 2. And don't forget, I have a plus or minus. So my solutions to this polynomial is x equals -1, 2, and I have -1 twice, so I can list it again. So let's list that. So -1, right, because it's squared. Then I have 2, and a +2i, and a -2i. So I do have 5 solutions, which, thinking about the corollary of the fundamental theorem of algebra, that is how many I should have gotten.